For this video, I'd like to talk about graphing parabolas. And you might recall from the last video that we started with the equation y is equal to x squared, which you can see is graphed right here. And we were able to graph this using a table, just picking particular x values and plotting what their y values would be. For instance, an x value of -2 would give you a y value of 4. And we basically just picked a bunch of key points, plotted them on the coordinate plane, and then connected them with a curve. So this is what the essentially parent function looks like, where this is essentially the simplest parabola that we can have. But our question in this video is, what happens if we, say, multiplied x squared out in front, or maybe added 3 or subtracted 9 on the outside? Or what if we had -4 times x plus 2 squared minus 8? Essentially, what do these graphs look like, and how are they different than this parent function? Or another way to phrase this is, starting with the parent function, how did we transform this to get to these other equations? So with that in mind, let's start looking at a few different examples. So here we have this first problem where we're essentially taking our parent function and then adding 3 on the outside. And when you add on the outside, what that does is essentially shift everything up or down by whatever many units this is. So in this case, we shift up 3 units. And the way to think about this is essentially each y value is now adding 3 to it. So recall, I'll draw the parent function in roughly, very quickly. And essentially, if you pick a particular point, let's say this point right here, since this is the vertex of the parent function, and essentially we want to know what happens to it when we add 3 on the outside. So remember, this was a point where x is 0, and in the parent function, y is equal to 0 there. But now we're adding 3. So we plug in 0 here for x, we square it, and we still get 0, but then we add 3 to that. So essentially, this point right here is now shifted up 3 units. And we can test this again with another point, like let's say this point right here, 1, 1. So usually in the parent function, when you plug in 1 for x and you square it, you just get a y value of 1. But now we're plugging in 1 for x, and when we square it, we still get 1, but then we add 3 to it, so we get a y value of 4. So instead of being at 1, 1 for the parent function, the point on this graph was shifted up 3 units to the point 1, 3. And you can make the same argument with the x value of -1. It went from being at 1, 1 in the parent function, or excuse me, -1, 1 in the parent function, and then that y value was essentially shifted up 3 units. And like I said, any point you pick along the parent function, to transform it to this function, all we did was essentially shift each y value up 3 units. Or in essence, what happens is the entire function gets shifted up 3 units. So when you're adding or subtracting on the outside, you are just changing the y values and essentially just shifting the function up or down. For instance, if we had y is equal to x squared minus 4, then for this one we would be shifting down 4 units. So adding and subtracting on the outside simply moves the function up or down.